One of the most common questions I get from aspiring IT professionals looking for career advice is this: what programming language is the most important one to learn? Well, my answer might surprise you. It's not Python or Java or any of those widespread technologies. Are you ready for this? The most important programming language is the one you already know and you've been speaking it your entire life. That's right. If you can understand the words I'm speaking, you already know the programming language of the AI era and just might not have realized it. In this video, I'm going to give a brief history of programming languages to show how they've evolved over the years so that we can understand how we got here, and then explain why natural languages have emerged as the most important ones going forward. Why do we have programming languages in the first place? Let's say you want to make a cake, because cake is delicious, right? You start with intent. That is what it is that you want to do. Then you translate that intent into instructions. Instructions in this case come out in the form of a recipe. Then you act on those instructions to get the delicious results, and that's the cake. Well, until recently, that's really how computers worked. You basically had to start with your intent. Let's say you want to make a computer program do a particular thing, like find all the different ways to make change for $1, which was my first programming assignment way back in the day. You translate those intent into instructions. In this case, program that is written in the language of the computer, not your language, the language of the computer. The computer then executes those instructions to give you the result. Now let's take a look at some examples of various programming languages and how they've evolved over time. So I'm going to start off with some of the most fundamental of these languages, machine languages. These are basically the way the machine expresses and understands in the most basic level. Machine language or assembler languages, which are even a higher level abstraction above that. And one of the major examples was the basic assembler language that IBM came out with for the System 360, the System 370, the mainframes, and all of those kinds of things. But lots of other systems had them as well. When I was in college, we were learning this. We were also learning how it worked on a DEC system from Digital Equipment Corporation, or an Intel system, which is, of course, the basis of a lot of the PCs that we use these days. So this was the beginning, but this was very much, as you can see an example here, this is very much not the language of people. This was the language of a machine. So the improvement then was to try to move to high-level language, higher-level languages that looked more human-like. And some examples of this, there was Fortran, the formula translation language, which was very specific for mathematics. There was COBOL, the common business-oriented language, which, as its name implies, used very much in business. The one that I really learned on initially, BASIC, was another programming language. But you can see examples of what these look like. These looked a little more like the way people talk, but not exactly, because people don't talk like that. Well, then one of the problems, though, with some of these languages, certainly their first generations, were that you ended up creating what people refer to as spaghetti code. You had to do a lot of go-tos and things like that. So you'd have code executing here, and suddenly you jump over there, and then you jump back over here. Very hard to follow. So the thinking then was to move toward structured programming languages. And with structured programming languages, you had things like PL1, cleverly named Programming Language 1. Who could have thought of that one? Pascal, which is another one. In college, they forced us to learn, and because this was really a teaching language. It was much more human-like looking, but it was designed to have a lot of restrictions so that you didn't make as many mistakes, because it was a strongly typed language. And then just the opposite of it, very loosely typed, so there was a big debate back in the day. There was the C programming language. Again, you had the ability to do more structure, not all of these go-tos and spaghetti code and jumping all over the place. Each one of these representing an improvement, but still not the way people think. And then object-oriented programming came along, and we ended up with a variation called C++ that was designed to allow you to think of programming as objects, and you would put inputs into the objects, they would perform certain functions, and you get outputs out. Structured programming was a similar kind of idea where you had modules, But here you're talking about them as objects, and you perform actions on the objects. C++ was, as I said, one of the big examples. Smalltalk was one that got a faithful following for a period of time. But then we moved on from object-oriented programming to basically the web came along. And we needed languages that would work in that space. Big ones here, Java, which the mantra here was write once, run everywhere. You could finally have a programming language you could write on one platform and it would actually execute on other platforms, which was a big advantage. Prior to that, pretty much you develop one of these languages, it runs on a particular platform, and then that's all it does. You'd have to recompile your code or do something else different, use a different variation on the language on a different platform. So this gave us some consistency, and that was really important because on the web, we didn't control what every system was going to look like. So again, you can see examples of what these are like. JavaScript was another in this case. PHP, another example of these sort of web-based programming languages. Then we moved to scripting. And actually, even though I'm laying these out as if they were separate things, we've had scripting all the way back well before. I was writing in scripting languages before using different ones that you probably are not familiar with. But scripting, for instance, the common one these days is Python. That's probably the most common one, but there are others. There's Ruby. So these are, again, higher level, and each one of these offering advantages over its predecessors. Then there was a move to come up with more safe languages. In other words, ones that didn't allow you to make as many mistakes. They would do some of the memory management and allow you to not basically put more guardrails around you. And some examples of this, Go is specifically for microservices and cloud environments, and Rust was another of these that would try to prevent some of these memory exceptions that would occur. So you can look at what all of these examples look like, and you can see an evolution. It's moving from the most machine, gorpy looking stuff to where it gets a little more human, a little more natural, a little more structured in each one of these examples. But then we moved to where we are now, the era of AI, and as I've suggested to you, natural language processing. This is where we go. We use this to feed into a large language model in the form of a prompt. And what do we put that in? Well, in my case, it's going to be in English. Okay, in your case, maybe it's Spanish or Portuguese or Mandarin or whatever, but you get the idea. We're talking to AI in natural language. What has basically occurred over all this time is the computers have gotten closer and closer to understanding us in our native way. So out of all of the examples that you've seen pop up over here, which one do you like best? Well, if you like this better than this, then maybe you're not a human. Now, instead of having to translate intent into instructions, which then get turned into results, we can go straight from intent to results and let AI do all the rest. Early computers required you to understand their language. I went to college for 4 years in order to get a bachelor's degree in computer science so that I could be a good programmer. But with large language models, we now have computers that understand our language. The beauty of programming in natural language is that it's just that. It's natural. You don't have to learn it. You already know it. The common language of computer science and the internet today is English, but there's really no reason why you couldn't also do this in Spanish or Mandarin or any other language you speak. Those are just examples of other natural languages. That's what AI, based on LLMs, can already understand. So good news. You lived long enough to see computers that understand you. Now, not everyone that wants to write code has to be a programmer, because you already know the most important programming language of the AI era. And the best part is that you've been speaking it all your life.